Hello class, and welcome again to Unit 12 Statistics, Day 2. Today we'll be talking about normal distribution. This is Mr. Dubé. Let's get ready to learn. I'm going to give you a moment now to pause the video and record these notes into your notebook. I think it would be a good idea to draw the normal curve in your notebooks. So, a normal distribution curve is a curve we can make which is symmetric over our set of data. And when we draw this normal curve, our mean will always be right in the middle of the curve, which means that to the left of my mean, so we could say this is x bar, to the left of my mean will be 50%, and to the right of my mean will be 50%. You could see that when I add up each percentage, I would get 50%. So these percentages, these are the percentages of my data set between my standard deviations. You see here that when I go to my left, I'm subtracting one standard deviation from my mean. I subtract 2 standard deviations from my mean and 3 standard deviations from my mean. You may recognize this curve from your reference sheet. Yes, we were nice enough to put that on your reference sheet. So let's look at how the curve is made. If we add the percentages, you will see that blank percentage lies within 1 standard deviation of the mean. So the key word here is within 1 standard deviation. So I'm going to be looking at between 1 standard deviation below my mean and 1 standard deviation above my mean. So that means that I'm going to add up 15%, 19.1%, 19.1%, and 15%. That is the percentage that lies within 1 standard deviation of my mean. So when I add that up, I get 68.2. These percentages, we're going to be using these percentages quite often. You might see questions that ask, how much lies within 1 standard deviation of my mean? And then this would be the percentage related to the data. So what percentage lies within 2 standard deviations of my mean? I'm just going to add the other percentages. So I go from 4.4 all the way up to the other 4.4, which is 2 standard deviations above my mean. When I add these up, I get 95.4. And finally, what percentage lies within 3 standard deviations of my mean? So I'm going to be starting from 3 standard deviations below my mean to 3 standard deviations above my mean. So this includes all the percentages from 0.5 up to the 0.5 again. When I add those up, I get 99.8%. Down at the bottom of our page, we have some very important procedures we're going to be doing whenever we see these notes. So take a moment and copy those down in your notebook. So let's take a look at our first example. The lifetime of a battery is normally distributed with a mean life of 40 hours. So we have our mean and a standard deviation of 1.2 hours. Find the probability that a randomly selected battery lasts longer than 42.4 hours. So I'm going to do step 1. I'm going to sketch my curve. So I'm going to have my bell curve, my normal distribution curve, and right here in the middle is going to be my mean. So we say that's x bar. I'm doing step 2 right now, which is I'm labeling. Always do these 2 steps whenever we are doing a normal distribution problem. So I have x bar equal to 40. Now let's look at 1 standard deviation. It says the standard deviation is 1.2 hours away. So if I move 1 standard deviation away, I would have 41.2 and 38.8. If I move 2 standard deviations away, I would have 37.6 and 42.4. Great. We just found the part of our question. Find the probability that a randomly selected battery lasts longer than 42.4 hours. So if I'm looking for longer than 42 hours, I'm looking for the probability that the battery will last longer than 2 standard deviations above my mean. So I'm looking to the right of 2 standard deviations. So this is plus 2, plus 1, 0, minus 1, minus 2. So referencing the normal curve on the first page from your reference sheets, what is the percentage above 2 standard deviations? When I look at my table, I get that we have 1.7% plus 0.5% plus 0.1%. When I add those up, I get 2.3%. What that means is that 2.3% of the randomly selected batteries will last longer than 42.4 hours. So going through the steps again, I sketched my curve. I labeled my curve, so I labeled each of the deviations, and then I was able to use that information by adding up the percentages in regard to what the question was asking for. Here's another great example. Example number 2, one of my favorites. 600 students took a test resulting in a normal distribution of the scores with a mean of 80 and a standard deviation of 5. So before I even think about my problem, I need to do step 1, sketch, and step 2, label. So I have my bell curve. I can label my mean, which is at 0, my x bar, as 80. Now let's look at one standard deviation above and below. So one standard deviation above and below, I would add 5 to my mean. So 80 plus 5 would be 85, and 80 minus 5 would give me 75. So looking back at our question, approximately how many students scored between 75 and 85? So what I'm asking is how many students scored between 75 and 85? Looking at the normal curve given to you in your reference sheet, all I know is percentages of the population. So we need to be thinking that my population size is 600, and let's use that information to find my answer. So I find by adding up the probabilities within one standard deviation of my mean. It was actually what we did right on that first page. It is that within one standard deviation of my mean is 68.2% of my data, which means that out of 100%, we can set up a proportion and find the percent out of 600 students. I would cross multiply. I find that x times 100 equals 68.2 times 600. X equals 68.2 times 600 divided by 100. This should be easy. This is a little bit of review. When I solve this on my calculator, I get x to equal 409.2 students score between 75, oops, that was a bad 75. Between 75 and 85. Alrighty, let's keep rolling. Take this time to take these notes down in your notebooks.